Very good afternoon to all of you and welcome to this session. This is the panel session 2 and the title of this session is Inclusive Growth of Entrepreneurs in Smart Grid. And we are thankful to have a galaxy of experts from industry as well as academia to be part of this session as a panelist. Let me just introduce all of them and then I will request the moderator to take over. So for this session, Professor S.P. Chaudhary, who is the founder of NBIRT in Kolkata, has kindly agreed to be the panelist as well as moderator for this session. Then we have Mr. Piky Agarwal, former Director Market Operations and Chief Information Security Officer in POSOCO. Welcome, sir. Then we have Mr. Swetang Jain, founder of and CEO of P2P Power India, and he is our alumnus of IIT Kharagpur. Welcome, Swetang. Then we have Mr. Saket Roy Chaudhary, MD Galileo Solar Private Limited from Kolkata. Welcome, Saket. And we have a long collaborative work for several years with Saket. Then we have Mr. Vishal Pandya from RE Connect Energy Solutions Limited. And I will go back to the brief bio available with all of them. Let me just give the name first. Then we have Mr. Devendra Gupta, CEO and co-founder of Ecogen Solutions. And we have Mr. Abhishek Manglik, CEO of Ecogen Sustainable Solutions. And we have Professor Chandan Chakravarti, who is also Associate Dean of Sponsored Research and Industrial Consultancy at IIT Kharagpur, as one of the panelists. So thank you very much to all of you. Let me go quickly with the brief biodata we have. S.P. Chaudhary is an electrical engineer from Jadavpur University and an international expert in the field of renewable energy, and he has served in government of Tripura, government of West Bengal, Northeastern Council for Promotion of Renewable Energy. He was director of Webreda, government of West Bengal, and also a special secretary energy to the government of West Bengal. He did pioneering work in the field of solar photovoltaic. His work in Sundarbans received worldwide recognition. He received National Science Academy Award, Asden Award from UK, Euro Science Solar Award from Germany for his outstanding contribution providing energy access to millions of people in this planet. He worked throughout the world, including different states of India, to provide electricity in the unserved areas. The mini grid concept was introduced by him in India's first 2 megawatt grid connected solar power plant in Asansol was introduced by him. He designed the first floating solar power plant of India and commissioned in 2014. He is presently the chairman of State Solar Power Committee, Government of Tripura. He is also visiting professor of IST Sipur. He is a fellow of Institution of Engineers India. Dr. Chaudhary traveled extensively throughout the world to realize his dream of energy for all. He has written 4 books on renewable energy. He is a member in Energy Expert Committee of Government of India. He is also the chairman International Solar Innovation Council, Helsinki, and he was conferred with DSc degree by University of Kolkata, received Shera Bengali Award from a leading TV channel. He has invented micro solar dome, which has become national program now and helping thousands of slum dwellers of India. Welcome, sir. Our next panelist in this session is Shree Piky Agarwal. He's a former Director and Chief Information Security Officer of Power System Operation Corporation Limited and an accomplished power system professional with 40 plus years of experience in diverse area of power sector. Now working as an advisor and expert trainer on electricity market design, digitalization, strategy, large SCADA integration, and OT cybersecurity. Advising on smart grid development in Central Asia as senior technical consultant to under Power Central Asia program of USAID. And he has also worked as consultant to USEA on project Digital Substation Technology, Kazakhstan Electric Power Grid Operating Company. He has played key role in development of electricity market in India and from its inception with the availability-based tariff in 2002 and open access in 2008. followed by power exchange, day-ahead market, cross-border energy markets, and recent launch of real-time market. Conceptualized and applied innovative technologies like blockchain, AI and ML in power system operation and markets. He has experience to complete life cycle management of and integration of supervisory control data acquisition system on renewable energy management center. Welcome to this panel session, sir. Next panelist on this session is Mr. Swetang Jain. He is a founder and CEO of P2P Power and has been actively involved in innovating event-grade clean technologies with a single focus, making this environment sustainable for future generation. He is a futurist and e-mobility enthusiast with a Bachelor of Technology BTech honors degree in electrical engineering from IIT Kharagpur and MBA from XLRI Jamshedpur. With a demonstrated history of working with power electronics manufacturing industry and skilled in advanced power electronics solution for power quality, energy management and electric vehicle domain, he has vision to develop technologies indigenously in India for the world. Started in 2006 at IIT Kharagpur, P2P Power has come a long way by providing high-end technology solutions that are currently being used globally by major corporate and industrial houses. P2P Power is on a mission to develop an ecosystem for innovations in India so that we can reduce our reliance on imported technologies. Welcome, Swetang, to this session. Next panelist on this session is Mr. Vishal Pandya. Sorry, Sekat Roy Chaudhary. Let's first. Mr. Sekat Roy Chaudhary is Managing Director at Galileo Solar India Private Limited and sole business partner of Kako New Energy from Germany. Power electronics has been in the area of key interest for a long time. At a very early age, he chosen his line of this profession with completion of BE and from BITS Pilani 2001 with a special emphasis on power electronics. He has also completed MBA from IIM Kolkata with emphasis on finance. Having considerable experience in designing solar power plants, he likes to design power plants at correct cost with the best bill of materials. Strong believer that India has stepped the wrong way as far as solar PV is concerned. The future is rooftop, not large size solar power plants in a megawatt scale. Welcome, Sekat, to this session. Next panelist in this is Mr. Vishal Pandya, and he is a co-founder of RE Connect Energy, India's largest digital energy platform scale-up. Vishal has about 12 years of experience in energy markets with expertise in renewable energy policies, predictive analytics, restructured power markets, and energy trading. His current role at RE Connect Energy involves strategic business development, utility scale business management, team building, growth, hacking, and everything else required to keep his organization growing. Vishal is an electrical engineer specializing in power systems from IIT Bombay and Chewing Fellow, St. Cross College, Oxford, with passion of clean energy markets. Welcome, Mr. Vishal. Next panelist in this session is Mr. Devendra Gupta. Devendra is an alumnus of IIT Kharagpur again. He has an in-depth understanding of clean tech, agri-value chain, aspires to disrupt the way purchasable and handled today. He heads product management, strategy, and finance for the company, and he has marshaled the product development initiatives and has led product design and market study for the product launches. He has been instrumental in building the team, strategy partnership, and raising fund at Ecogen. He is unreasonable fellow. He is also a part of Confederation of Indian Industry and Task Force for Cold Chain and part of Renewable Energy Committee of National Center for Cold Chain Development, NCCD. He has also been time and again a part of various agriculture and cold chain forums chaired by key leaders in the country. It is under his leadership that the company has been recognized with the numerous awards such as CIA Award for Innovation in Cold Chain in 2017, FedEx Small Business Grant 2018, RoboFord Lost Challenge in 2018, and Best Startup Pune Connect 2014. He has been also among 50 most influential sustainability leaders list in 2017. He believes that we live in one of the most exciting times in the history where technology-enabled business model will address the long-standing issues. Welcome, Devendra. And our next panelist in this session is Mr. Abhishek Manglik, who is a founder and CEO of EcoSense. After completing graduation in mechanical engineering from IIT Bombay in 2004, he worked in HPCL for 2 years with a great enthusiasm for new and upcoming technologies, and keenness to create a product of value he left HPCL to start entrepreneurial journey. Prior to founding EcoSense, he co-founded the first company, V2Learn, in the field of online education, way before EdTech revolution of India. He handled it for 4 years and then moved out to set up EcoSense Sustainable Solutions in year 2010. At EcoSense, with his vision, backed by the great team, they created much needed equipment in renewable space to teach upcoming generations and about renewable energy and green technology. Today, EcoSense boasts of 500 educational institutes in India as their clients. Great. Thank you, Abhishek, for joining this session. Next panelist in this session is Professor Chandan Chakravarti. And Professor Chandan Chakravarti has received BE and ME in Electrical Engineering from Jadavpur University in 87-89 respectively, and PhD from IIT Kharagpur and Mia University, Japan in 97-2000 respectively. Presently, he is a professor in Department of Electrical Engineering and Associate Dean of SRIC. Here, his research interests includes power converters, motor drives, electric vehicle, renewable energy. Dr. Chakravarti was lead of UK India project on reliable and efficient system for community energy solutions. Currently, he is India side lead for UK ICRI project, a consortium for both India and UK side with the IIT Kharagpur Lead Institute. Dr. Chakravarti has received JSPS fellowship to work with the University of Tokyo. Also received many awards, including IEEE Vimal Bose, Avinash Gupta Chair Professor, and contributed on several technical programs. Now, he is also served as associate editor on various IEEE journals, and he has also served as co-EIC of IEEE transactions on industrial electronics since 2000, during 2018 and 19. Presently, he is editor-in-chief of IEEE Journal of Emerging and Selected Topics, Industry Projects, and he is also fellow of IEEE and Indian National Academy of Engineering. Welcome, Professor Chakravarti, on this session. Now, I request Professor Gan Chaudhary to take over and kindly moderate the session. Sir.
Well, good afternoon to everyone. Thank you very much, Dr. Pradhan. Now, I find we have about 1 hour and 10 minutes time, and we have 7 speakers. So I can give only 10 minutes to each of the speakers. I will go accordingly. Now, I'll give a small introduction to this, the topic, development towards inclusive growth for sustainable and decent grid, smart grid. Grid uses a limited one-way interaction. That is, power flows from the power plant to the consumer. This grid was introduced long back. It is a old grid, old system in 1882. The smart grid, in contrast, introduces a two-way interchange where both electricity and information can be exchanged in both directions between the power utilities and the consumers. The smart grid also allows for renewable energy technologies such as wind and solar energy production and plug-in in electrical vehicles. Grid becomes more efficient. Now, the main point is, now I should request the speakers, they should discuss, keeping in mind the recent Glasgow Convention 26 COP, where India has committed 500 gigawatt of solar power by the year 2030, and how this entire 500 gigawatt of power will be integrated in a smart grid like Indian grid. That point should be highlighted properly, which will be really beneficial for the audience. You see, we should not discuss on a lot of theoretical issues, but we have a commitment. Our Prime Minister has announced this 500 gigawatt of solar power, and he has also declared about one sun, one world, one grid. He has also announced about that. Very interesting topic. So I would request everyone to give some emphasis on this particular topic where India is committed, and so that by 2030 really we can achieve our target. I know you will be discussing on various issues. You are most welcome to discuss, but keep it in mind that in COP26, we as an Indian, we have given a commitment that we will go for 500 gigawatt of solar power. So how this 500 gigawatt of solar power will be integrated and renewable power will be integrated with a smart grid, that point is very important in today's context. So I would request everyone, I will not take much more time. I would request everyone to keep it in mind, this particular issue while addressing the gathering. So we have, as I have mentioned, we have 7 speakers. We don't have enough time also. I don't know whether I will be able to give time to the audience for questions, but without wasting further time, I would request Mr. Piky Agarwal, who is former Director Market Operation and Chief Information Security Officer in POSOCO, to start his presentation, and gradually I will go on. Introduction has been made by Dr. Pradhan already. You are all aware about the speakers, most large speakers we have in this session. So I would request Mr. Agarwal to start his presentation. Mr. Agarwal, please.
Thank you, sir. I don't have any presentation. I will talk on the points. So, good afternoon, namaskar. And first of all, let me express my thanks to organizers of ICPS 2021 for inviting me, and a very good topic for me. And this topic is close to my heart. Since I am first speaker, so I will deal with the basic of smart grid and how this smart grid is benefiting grid operators, benefiting utilities, and benefiting all domain of consumers. Very important link in the complete supply chain of electricity supply. So, and then lastly, then I will just go through that how this entrepreneur will benefit from the smart grid, and how this renewable energy will be integrated, and we will be able to integrate about 500 gigawatt target of renewable energy in the smart grid. So the evolution of smart grid is the most important and potentially the most beneficial thing to the happening to the electric industries. And adopting smart grid technologies, this is not the choice. It is a need of our, because we want to integrate so much renewable energy, clean energy resources, EV storage, and many things. So we have to, and that all this integration and proliferation of different type of resources, which are variable, non-predictable, and intermittent. So we need that smart grid. So we need smart grid due to the need of optimized use of limited resources. So resources are not abundance, and they are limited. So we need the smart grid for the optimized use for that, and need to protect our environment. This is very significant requirement of smart grid, need of smart grid, and that's why we are going for clean energies. And the need to integrate clean energy resources which are inherently variable, intermittent, and unpredictable, as opposed to the conventional resources which were very stable throughout the day or throughout the month. So smart grid is needed for handling alternative energy resources like rooftop solars, flexible loads. Flexible loads is also a resource for the energy, EV, electric vehicles, and different type of storage. So many type of storage are innovating. Yesterday we heard Mr. Mani Baradri, then he presented so many different type of storage, and these all storage are need to be integrated. That's why we need a smart grid. And these storage are distributed, more granular, and handling the more granular and distributed resources, we need the applications, technologies. And one more thing, these storage, these resources also moving from centralized generation to the edge of the grid. So which was basically not designed for that DERs. They are designed for the for supplying the power load, and that also one way. So all these needs a smart grid, and successful implementation of a smart grid needs innovative and solutions oriented technology, because the basic of smart grid basic smart grid has already been implemented, and now we need innovative solutions. And smart grid means the electricity supply system which is capable of benefiting utilities, benefiting consumers, and benefiting stakeholders, either connected directly or indirectly. So there are many ways smart grid is transforming the present electricity industry, electricity grid. I will deal about 4 or 5 very important points, and how the smart grid is benefiting and how this smart grid is transforming that. So one is it is transforming the grid in an efficient electric system with the lowest possible cost to consumers. This is very important. So it is efficient electric system with the lowest possible cost to consumers, and it enables the efficient use of existing resources. So whatever existing resources are there, it enables us to utilize those resources efficiently and optimizing the consumption of electrical energy. So this was the one. Then second is it is also transforming the system in a highly reliable system. So reliability is very, very important, and self-correcting and self-healing. Like ring main units, if you see this distribution system, ring RMU are used where if a location, one feeder which was feeding the location is tripped, then automatically the power will come to other feeder. So like this, many technologies is transforming this grid in a reliable, self-correcting and self-healing system. And moreover, new technologies like AI, ML based action awareness, situation awareness, they are giving the tools to grid operator so that they can take proactive actions and deal with the probable or impending contingencies. So this was the second. The third is an environment friendly electric system. So a smart grid is creating a environmentally friendlier electric system, and which is, I think, is the most important requirement of implementing the smart grid and integration of clean energy system. So as a technological achievement, smart grid provided the solution of past issue like carbon pollution, generation of carbon reduction, carbon footprint, and development of a most sustainable future. They consist of deployment of green energy system which helps in the reduction of carbon or CO2 emission. Then fourth is system in which customers have choice and control. So to me, this is the most important thing which smart grid is happening. The consumers are empowered and they have full control on their consumption. So the most significant element of the smart grid, it empowers customers by giving them all the information required about their consumptions. And system like home energy management system, it has become so advanced that it can bid on the behalf of consumers without real-time interaction. So if consumer can feed their preferences for the temperature of home, for the scheduling of their washing machine, and the home energy management system will automatically bid in the electric market and provide the energy at a least cost to the consumers. Then it is also transforming the grid as a system based on technological foundation from which it can continue to evolve, improve. So smart grid has provided a basic system which has many technological foundation, but it requires to evolve in the future. And this is the point when we have our entrepreneurs will require to play their role, and they will have the good growth on this. They can develop many different type of innovative solutions which solve the pain point of the grid operator, the pain point of the consumers, pain point of the utilities, and then so we need to continuously explore the requirement of the grids, requirements of the stakeholders. And for example, I will give some example on how these entrepreneurs can use this basic technology and do the innovative job for the smart grid and the benefit of consumers. Like AI solution, AI can play an important role in understanding how changes to one part of the system would affect the other part of the system. For example, in grid operation, there are thousands of reactors. So AI ML can be used for, and it's very difficult to for an operator to keep track of all the reactors are on or off. So we can have AI ML type of applications which can initially provide the alert to the grid operators. Then based upon the voltage profile of the grid, we should use this. We should put on this reactor, put off that reactor, and then later on it can be developed to automatically managing the reactors. Other is a big data. Big data, because of smart grid deployment of many thousands of millions of sensors in a smart grid, a very high volume or velocity of data is being produced by different operations in the smart grid. And then any person can use this data and give the predictive analysis and how this grid will move and how the development of industry will move. So this is other type of application. Then increasing number of electric vehicles, smart homes, and many more subsystems are likely to interface with utility and provide them with potentially valuable data. And by studying this data, entrepreneurs can develop systems which gives the behavior of consumers, behavior of different system, different elements of the grid. Then improved understanding of consumer behavior, because grid or smart grid, everything is being developed for the purpose of supplying the electric supply to the consumers. And if we know the consumer's behavior in advance, in future, how this load will grow and how the consumer behavior will affect the consumption of electricity, then it will be very useful for the development of future plan. And this big data analytics play a role in this. So like this, there are many applications. I think this time will not permit to reiterate all the application. So like this, smart grid is benefiting the electricity network, electricity industry, and entrepreneurs can use these different basic technologies, data, and emerging technology to get benefited. Thank you.
Thank you, Mr. Agarwal. Thank you very much for explaining the smart grid in a larger way, in a proper manner, and how consumers, mainly our target is consumers, how consumers will be benefited from the smart grid, and how we will integrate the bulk power into the smart grid. May I now come to the next speaker? Again, I will tell you that only 10 minutes time you have. Mr. Jain, you are the second speaker. Mr. Jain is the founder CEO of P2 Power India. May I now request Mr. Jain to deliver his lecture?
Thank you, sir. Thank you. So I'll be discussing about the recent subject of EV charging, right? So the integration of EV charging with the smart grid, that is something that will play a major role with respect to the energy consumption, which is going to increase drastically in the electrical grid. And the integration of solar along with the your EVs will actually impact the overall electrical grid in a big way, and we need to take a lot of measures upfront to take care of the load management as well as your load side management, plus smart charging needs to happen along with in the smart grid, so that the consumption is not increased only for a certain duration. It is balanced out across the entire day. So before I go into I'll brief you about what exactly EV charging is and what are the various types of charging, as well as, so you will have a brief idea about EV charging through this presentation. Just one second. Yeah. So I'll just give you a brief. So basically there are two types of charging, AC and DC. AC chargers are using the onboard charger inside the car to charge the battery, and then you have a DC charger which is directly charging the battery. So there are three particular standards being followed for AC charging. This is a 3-pin socket, type 1 and the type 2. And in DC again you have three standards. That is your CHAdeMO, your CCS, this is CCS, and this is your type 2. So type 2 and CCS, plus there is another standard, that is the GBT, which is not mentioned here because we don't, that is getting obsolete. In fact, CHAdeMO is also getting obsolete. In India, mostly this combo CCS2 will be used in the near future. Then the other way of charging is the swappable battery. This is being used for a lot in the 2-wheeler and the 3-wheeler segment specifically. So these two methods are essentially used for charging the electric vehicles. Then if I talk about the type of charging, it can be actually based on locations as well. So private charging is something what we would do in our houses. So the load requirements in the house is actually going to double up. Currently, most of the power requirement in a particular household is around, say, 5 to 7 kilowatt or up to 10 kilowatt. But a single charger for a EV would be typically, minimum rating would be 3 kilowatt, 3.3 kilowatt. And normally what people will be using, a type 2 charger for cars will be 7.4 kilowatt. So all these things will actually have a major impact on the grid with respect to the load requirement. Similarly, then you have semi-public charging, which you can say the malls, your office buildings, commercial complexes. These are all semi-public areas. And then you have public charging, just like petrol pumps, open areas where the cars can go, get charged and move forward. Yeah, so this is, that was about the type of charging with respect to the load. Then when I talk about the connections to the grid, connections to the smart grid, and how these chargers will be interacting with the grid. So there are basically three ways in which this would happen. One is when we draw power from the existing power connection. That could happen, say, directly through an energy meter. We have a transformer, then we have a meter, we draw it from there. Or we create a captive generation where you have your solar, you have battery banks, your battery storage, and then you charge the car. So there are these three methods of drawing electricity for the electric vehicle charging. Then you have this minus metering. This concept is actually very good, and this is something which will be used a lot in most of these charging infrastructure. And this basically means that if, say, there is a mall or there is a big facility which already has a big connection in place, so they can create a sub-meter and provide connection to all the EV charging infrastructure, and the bill will automatically be adjusted. That's why it's called minus metering. So this meter, the value of this meter will be minus from the overall meter, and this will be billed separately as an EV meter, and the remaining meter will bill you the bill for the remaining energy. Then you have the net metering concept, which is very popular in solar, and that same net metering, when extended to EV charging, will actually enable the cars to become battery banks. They will enable the cars to become to act like complete UPS systems, which can power up the houses and which can even power up the grid, which can provide support to the grid in times of huge demand. So the V2G and the V2H concept comes from here. And this is where the net metering will play a very major role. So this is that concept. Now, when I talk about the load profiles, like all the DISCOMs are currently doing a lot of study with respect to the kind of enhancements they have to do across the system to be able to cater to the EV requirement, EV charging requirement, which is going to come at a later date. Some of the markets like US, Europe, they are ahead of us. China, all these markets are much ahead of us, almost 7-8 years or 10 years ahead of us with respect to the number of EVs which are already there and the charging infrastructure which is already getting set up. So we took a typical example of the kind of load profile that the DISCOMs see in, say, California. So you will see that there during the night time, major charging happens. And in this particular segment, most of the charging is happening in the households. It's all residential charging. Similar thing is going to happen in India. That 80% of the charging will be home charging. Public charging will be limited because two reasons. One, that it is fast, so it affects the battery in the long run. Second, it will be expensive. And considering that India is a price sensitive market, home charging will be the best suited charging option for them. And in fact, that is what we are seeing even in US. It's not just about India. Even in US, fast charging is a very nominal part of the entire load curve. And this entire load curve then can be managed through different sources of energy. Like if we are able to generate solar energy during the day, during this time, when the EV charging requirement is less, that energy can be stored using energy storage or different means, and then can be supplied during the night when the peak demand will occur, essentially. So all these things are only possible when all the things are smart, starting from the grid to the last part, that's the car. So the cars, when they're connected to the chargers have to be smart enough. There has to be active load management implemented within the chargers. Then all these software platforms need to be smart to be able to interact with each other and should be able to provide data to the DISCOMs so that the DISCOMs can take action accordingly. So all these names which you are seeing, OCPP, OCPI, Open ADR, these are different protocols which have been developed to standardize the interaction between these platforms. So when there is an interaction between the CMS system, between two CMS systems, it is done through OCPI, and all the chargers are basically OCPP compliant. So any charger talking to a third party CMS has to do it on an OCPP platform. Similarly, OpenADR is a basically demand response platform where all the data of whatever is happening here is basically communicated to the DISCOMs, and based on the time of the day tariff or based on their load scheduling, they can actually give commands to the CMS and eventually to the charger to charge up to that certain limit. So this entire thing actually makes the entire thing extremely smart, and this is what will happen in the smart grid. This is how the EV chargers will get integrated with the smart grid, and the smart grid will be sending out commands to each and every individual charger with respect to the amount of power it can supply to the car, how much it should charge, when it should charge. All these things will actually can be monitored and implemented through the DISCOM level. So this is from my side.
Thank you. Thank you, Mr. Jain, for explaining the integration of EV charging infrastructure in smart grid. Thank you very much. Now we can just go to the next speaker, Mr. Shaikat Rai Chaudhary. He is from MD Galileo Solar India Private Limited. He is MD, Managing Director. I know him. He is working in this field, particularly solar energy and other area for a long time. So may I now request Shaikat to make his present. You have a presentation or you will be speaking only?
No, sir, I will be giving a small presentation.
Okay.
I will
You give this presentation, but it should be short. Keep it in mind, you'll have only 10 minutes time in your hand.
Right. So basically what I will be talking about, what I would like to discuss is in the future, the energy, the way in which we are using this energy will change, right? So from the point of the consumer, what is being planned or what is already in progress is that you are integrating various kinds of renewable energy into your system. Now, this with the battery bank or the storage system coming into play has got a very important role in the smart grid application. So what I want to do is that I will share my presentation. Okay. So in the future, what a typical in each of our households, what we will be actually looking at is that we will be looking at a system which will be considered as two buses, right? You will have the DC bus and you will have the AC bus, and you will have a bidirectional converter which is going to communicate between the AC and DC bus. So the different storage systems like solar will be interfacing on the DC bus, the battery bank is on the DC bus, the wind will be on the AC bus. So you will have a common platform, right? Maybe a 220 volt bus for systems up to 5 kilowatt to 7.5 kilowatt, and maybe 200 volt or 120 volts. We don't have a standard yet, but we are going to have a standard on which the storage system is going to be connected, and along with that you will have the PV system be connected. And overall we will be having something which is called the energy management system, the EMS. The EMS is going to be the guy who is going to control these different sources, who is going to talk between the different points of generation, and also be it will control how much of power is going into the grid, how much of power is coming from the grid, how much energy is being stored in the battery bank, which source of power is being utilized first. So it will act as an energy optimizer in the whole system. Now, what is very important to note is that we do not, at this point of time, we do not have a method of interaction between the grid and the load, which is connected at the customer side, or the generation which the customer is doing, right? So this EMS will actually provide a link between the DISCOM and the consumer or the generator, however you look at it, right? Now, what is it that we are actually looking at, right? These are the few technologies which is going to come up big time, right? Which is going to be used for the grid stability as well as for optimizing the use of energy. So we are going to look at power factor, right? How the role which we have as consumers in improving the power factor of the grid. We will be looking at peak load shaving, which was just pointed out now. Then we have this opportunity for energy arbitrage, right? And then we have the different consumption technologies or metering techniques, right? How we are consuming the power, right? So in India, we started off with net metering, then we have gross metering. In Europe, you have feed-in tariffs. So how each one of this needs to be controlled, we'll try to look into that. Now, all of us must be aware that in Germany, their grid is now a smart grid where they have trading, right? Plus the solar inverters producing power actually talk with the DISCOM, right? And they are able to generate kVAR. So the problem which they had was that they were generating enough active power, but reactive power was not being generated from the grid. So I'll take you through a small example, right? That if you look at a normal situation for a customer who is consuming power at say 0.8 power factor. So what he is demanding from the grid is 8 kilowatt of active power and 6 kVAR, right? So his net power requirement is 10 kVA. His power factor is 0.8. Now, in this system, what I do is that I put in a solar inverter, right, which starts generating 4 kilowatt of active power and 0 reactive power. So now what happens is that my generation has gone down, my requirement from the grid has gone down from 8 kilowatt to 4 kilowatt. But my kVAR requirement remains at 6 kVAR. Now you see that my power factor, if I put it into the same graph, you will see that my power factor has changed. It has reduced to 0.55 from 0.8. So basically, the problem here which we are facing is that our systems are not generating reactive power. They are concentrated on generating active power. Now, the question comes is that how much of active power, how much of reactive power is required? So just look at this chart. In this chart, basically I have a 10 kilowatt solar inverter, right? Say it is connected with 10 kilowatt of panels. In Indian conditions, you do not expect a generation of more than 8 kilowatt at the peak. So if my inverter is rated for 10 kVA, right? So if I am generating 8 kilowatt of active power, I can still generate 6 kVAR, right? And if you see that during the different points in time in the day when your generation is less, you can actually control the amount of you can see that we can generate as much. If you are generating just 1 kilowatt of active energy, the same inverter has the capacity to generate 9.95 kVAR. That is the capacity which it can do. So in this example, if I go back to my previous example, if my active energy is 4 kilowatt, my inverter can actually generate the 6 kVAR of power, right? So I do not need to depend on the grid to provide me the kVAR, right? So what we are going to see is that right now our meters do not measure for domestic consumers. They do not measure the power factor. But in the future, we are going to see that there is going to be a communication where it will be required that the solar inverters actually generate kVAR and the DISCOM or the utility will actually buy kVAR like they are buying real power. They will actually be looking at buying kVAR. So we will see that you will have an active trading of power reactive power. What we are having for active power today, we will have reactive power trading, and this will be through an energy management interface. The second technique which we are looking at is peak load sharing, right? You know that whenever we apply for an electric meter, it is by mandate we have to apply for a connected load. Now, even your computer, when it starts up, it takes 1.5 times rated current, right? For the larger machines, it may go up to 3 times, 4 times the rated current, right? But you don't require. So in this example, you see that I have a running load of maximum 50 kVA. But for a very short duration, it shoots up to 75 kVA. Now, by Indian electricity rules, you need to apply for 75 kVA meter. Else, there is going to be a huge penalty, right? But now, if you have a system which senses when your power goes above 50 kVA, and what it does is that with the help of the battery bank, it starts discharging the battery for 25 kVA. So you are left within the limit of 50 kVA. So number one, that the grid becomes more stable. The fluctuations which are happening on the grid is reduced. Plus your energy, your connected load is also balanced. The second, this is in the rural sector, this is the electricity bill for commercial applications, right? So you see that you have TOD tariff. In the TOD tariff, between 5 o'clock in the evening to 11 o'clock at night, you are going to pay a tariff of 9 rupees 85 paisa for each unit of electricity consumed. Now, add to that government duty of 10%. So you're looking at nearly 11 rupees as your electricity bill. Whereas if you consume the units at from 11 o'clock in the night to 6 o'clock in the night, what is going to happen is that it's 464, only 4 rupees 64 paisa. With TOD, it is going to be around 5.5 rupees. So it's exactly half. So all you need to do is that you're going to charge your battery banks during the night and you're going to discharge it during the peak hours. Now, what is the implication on the grid? On the grid, the peak tariff happens because the consumption is most at this point of day. So you're actually smoothing out the curve. The peaks which are there, you're smoothing it out. And for the customer, he sees an energy arbitrage of 5 units, which should be in the very near future. You will see that the commercial malls, etc., which are running, they will employ this simply because it results in huge savings, because their load is actually from 5 o'clock in the evening to 11 o'clock, 12 o'clock in the night. So there's a lot of savings for them. Now, we are aware of the various metering strategies, right? In the different parts of the state, different metering strategies. In our country, in West Bengal, we still have net metering, but it is going to be replaced by gross metering. In Delhi, we have gross metering. So there are different metering technologies, right? So here is the example of net metering. In net metering, whatever is my purchase cost is the same as my sales cost, right? So what we are going to do is that because the purchase and sale is same, it doesn't make sense in storing because there is a storage loss. So we don't, and there's an investment in the storage. So we don't store at all. We always use the grid as a storage system. But if you move to gross metering, in gross metering, if the rates are good, then you will export to the grid. But normally the rates are bad. So if the rates are bad, what you will do is that you will charge your battery bank to be used in the evening so that the curve flattens out. Similarly, with feed-in tariff, you will always try to sell all the power which you have to the grid. Now, these different technologies, right? And along with that, you have these different interfaces, right? So the next big thing which is coming up in this market, which gives a lot of emphasis is to the different entrepreneurs, is that you will have to design this EMS. This design is not going to be simple because you will have different sources of power, right? Like wind is unregulated, right? So there is to be a point when you're going to switch off wind, right? Biogas is regulated. You can control how much of biogas is being consumed. So you need to have the energy system has to be customized to the situation. Along with that, you have the metering strategies, whether they are opting for net metering, whether they are opting for grid metering, whichever strategy they are opting for, it has to be customized according to them. So here we will see that a whole new plethora of energy companies coming up who are going to handle this micro level of management for your house, right? So you will have people who will be implementing solar. You will have people who will be introducing storage technologies. Be it in the form,
you have to wind up now, Saika.
yeah, be it in the terms of storage systems. So here you will see a lot of entrepreneurial environment to adopt this new technology. Thank you.
Thank you very much, Shekhar. You have explained distributed energy system, stability of the grid, and lastly, metering, net metering, gross metering, and feed-in tariff. You have explained nicely. Now, may I go to the next speaker now? Vishal. He's from RE Connect, Bangalore. Vishal, you are there?
Yes, sir. Hi, good afternoon.
Good afternoon. So you have presentation?
Yes, I would prefer to show some slides. And
you should keep in mind that you should finish it within 10 minutes time.
Sure, sir, sure. I'll just share my screen and get started with that. Yes, is my presentation visible?
Yes.
Yes, so our core area of work revolves around grid management, integration of renewables, and applying new age technologies around AI, remote sensing, and IoT. And the way we see market evolving is basically the entire landscape is changing very rapidly. We have very large, ultra mega renewable assets coming along in the grid, and this is a global phenomena. Very large solar and wind assets getting connected to the grid. So any weather impact that happens to this asset, again, it will cause imbalance in the grid operations. And the conventional generation, on the other hand, is now acting, or rather expected to act more like renewables. Means that they need to vary their production based on how the other ecosystem is playing around, starting with renewable and consumer demand. The grid operations are getting more and more challenging as we see, because of many variable source of energies, starting with renewables, then EVs, and then battery energy storage system will all start playing an important role in the grid management. And then the storage, EVs, DERs, hydrogen, smart consumers, a host of new ecosystem players are going to evolve, where the grid itself will change quite radically from what we have been seeing so far. And coming to renewable, a lot of emphasis is being added that we will have 500 gigawatt of renewables. If you look at wind alone, we did this analysis, a yearly load duration curve for a state in Western region and for entire region having multiple states, about 15 gigawatt capacity in Western region and about 2.5 gigawatt capacity, say in MP. And one thing that stands out is that only 20% of time in a year, the overall wind production crosses 30% of installed capacity. So if you have 10 gigawatt wind asset, only 20% of time in a year, you will see 3 gigawatt of production being injected into the grid. And you can imagine the kind of transmission and distribution assets that are required to be managed in order to accommodate this type of energy. And the level of variations that we see are also kind of significant. And if you look at some of the states, here I'll quickly scan through a few of the states, an example in terms of how realistic it is for us to have 500 gigawatt in our energy ecosystem. So MP is a very interesting example. Installed wind and solar is about 60% of average demand. When it comes to consumer behavior, climate, renewable, political events, all of that plays a role. And it makes it more challenging for the system operators, the distribution companies to keep balancing their energy needs on a day-to-day basis. TN is another interesting case. The average demand is about 13.5 gigawatt, where installed RE itself is about same level. And the peak demand is slightly above the installed capacity in terms of renewable. So you can see that we are pretty much hitting certain thresholds in terms of installed capacity. In terms of energy terms, here we have summarized some of the annualized events in terms of how has been the contribution from renewable vis-a-vis total demand. And here you see a completely different picture. While the installed capacity is very large, we see that not even 20% of demand in Gujarat is coming from wind, solar, and hydro. Hydro is very small. Wind is sizable and solar is picking up now. This is for entire calendar year 2020. Look at Maharashtra, it's even smaller. MP, quite sizable contribution from hydro, which also helps them to balance their intraday and weekly variations in energy quite successfully. Tamil Nadu, if you see, almost same installed capacity as average demand, but you can see that about 30%, 35% of energy starts getting contributed from wind by and large, and then partly by hydro during the high wind season. And we are still far off in terms of reaching 80%, 90% levels from renewable. Karnataka is a very interesting state. Throughout the year, you see that almost 40 to 50% of energy coming from wind, solar, and hydro stations. Karnataka is very rich in hydro, and there are instances here, like for example, you see close to 100% of your energy at times come from all three sources alone. And that signifies that while there is still headroom for growth, these are the areas where it will become quite challenging for the host utilities to balance the supply demand and also dispose of the surplus capacity which would come from renewable source of energy. Overall, from the dispatch point of view, what we are seeing is that there is always a constant push and pull in terms of the must-run status which is given to renewables. Uh, the the innovations that are happening in the power market sides, where we have variety of contracts around electric demand, real-time market, power exchange, spot market, and then long-term, medium-term, short-term open access contracts. And for utility, it's very important to see that they don't lose out while having so many ecosystem players trying to maximize the benefit. And some of the technology trends what we are seeing, and these also could create opportunities in terms of creating new value for the host of players, starting from generation to distribution and also transmission. Some of the areas where we are actively involved is that you predict renewables, you predict electric demand, you do the prediction up to season ahead. Now, can you also look at autonomous dispatch? So you keep looking at all the contracts. You have a good grip on your demand forecasting, your RE forecasting. Of course, there will be errors. So you also need to get a handle on those errors and keep optimizing the decisions around power procurement and dispatch to the grid, starting with hour ahead dispatch, day ahead dispatch, week ahead dispatch, and seasonal dispatch. And a lot of utilities are now moving towards this direction. Our integration, India has apparently taken significant level of efforts, gone beyond what other even developed countries are doing. So we have developed a very interesting concept around having dedicated renewable energy management centers. We have been part of 11 REMCs that are fully functional and operational across India now. And what you can see in the block diagram is that it's totally AI and automation driven system where multiple forecast inputs are provided. Best forecast out of all the input forecast is created, optimize it further, and then all of renewables are getting dispatched through a centralized dispatch platform. If you look at another major trend where sizable government budgetary support is coming is basically digitalizing the wholesale electricity market, and where you look at a host of digital tools around open access, load forecasting, energy accounting, billing, MIS reporting is happening across India now. Many large number of projects are coming up, supported by the state utilities as well as the PSTF funding. Some of the key trends which are evolving is that purely from the market and the reforms point of view, we have seen massive changes in the power market regulations. Real-time markets are now almost 20% of the overall day-ahead spot market. And with the overall outlay on the prepaid and flexible smart metering point of view, if you see, close to $56 billion, 3.5 lakh crore rupees are required to be invested in the system. And a sizable chunk of that is also expected to come from various state and central governments. The electricity derivatives are again going to open up a whole new lot of initiatives in terms of how your energy is managed and how the retail folks, the ordinary consumers like you and me, are going to start taking some form of position in the mainstream energy market. And here, if you see, the markets are becoming fast, new age ecosystem players are coming. The customer is already smart, and the customer or a consumer of electricity is going to be fully digital and very proactive in terms of interaction with the market. And a lot of new age ecosystem players like distributed energy resources, EVs, and battery energy storage system. A host of new reforms and the power market evolution is going to happen in next few years and not even next decade. And it would be very interesting to see that how we are going to capitalize as a country in terms of creating indigenous solutions, creating technology layers which are free from any form of imports, and which also goes in line with the Atmanirbhar Bharat and Make in India initiative. So with that, I would like to close my session. And if there are questions, would be happy to answer after the event. Thank you so much.
Thank you, Mr. Vishal. You have discussed about the grid of the future, energy balance. I like the penetration of renewable energy in different states of the country that you have mentioned properly: Maharashtra, Madhya Pradesh, Karnataka, Tamil Nadu. These experiments are going on now in the country, which is very important. The penetration of RE into the grid, which is really intermittent in nature, but even then we are penetrating in this smart grid. You have also mentioned about Indian grid and Indian power market. Thank you very much.
Thank you, sir.
We will very quickly go to now next speaker, Mr. Devendra Gupta. He is CEO and co-founder, Ecozone Solution Private Limited. Mr. Devendra Gupta, you can start and keep it in mind. You should finish it within 10 minutes. Within 10 minutes, not more than 10 minutes.
Sure, sir.
Okay.
Okay, thanks a lot, sir. I just want to very quickly give a background on what Ecozone is doing. We as a company are working to provide off-grid devices for powering agriculture. We have provided solar pumping and solar cooling solutions from both pre-harvest and post-harvest perspective so far. And what we are seeing right now is that all these devices are off-grid and they do not really have any configuration to make them smart grid ready for the future. So we see that as a very important area where interventions are needed. Just to very quickly share that a lot of devices in India are running using diesel. To address that, this is the kind of solution that we developed as a company, wherein you can run a irrigation system on solar. And to address the food loss issue, we provided a system called EcoFrost for enabling solar-based cooling. So what we are seeing is that when we are working with these different off-grid devices, in future, when grid reaches them, they need to be able to export their power to the grid. Because today, a lot of these devices are having their energy wasted. Wherein the energy is not, when the systems are not in use, the energy is getting wasted. Okay. And if you are providing batteries like low maintenance lead acid batteries, they are not again very efficient and they are likely to get bad in the 3 years or so. So by the time the grid reaches there, they would still not be functional or will not be useful. So what we have been doing as a company is to provide solutions such that instead of providing the LMLA battery, we provide a different kind of energy storage, which is more relevant to the type of application we are focusing on. For example, in case of a pumping system, we tend to store the water high on a tank, wherein we are storing the energy in the form of potential energy on a tank. And when it is required during the time when the sun is not there, it can be just pumped using the potential energy on the tank. In case of a cooling system, we are converting water into ice to be able to provide this energy at a time when the sun is not there. What we be a critical thing to do, because in future when the grid is having additional too much of power being injected by solar, the energy can be stored in these kind of energy mediums, which are very environment friendly and cost effective. And further, this is more efficient as well as compared to the chemical batteries per se, because you're storing the end effect and there is no longer a conversion of electrical into chemical and then back to electrical taking place. So we feel that the off-grid devices like this, which are not about just providing electricity, but providing some utility, need to have a relevant storage infrastructure. Plus, they also need to be able to export power to the grid when the grids come to them. So it is important to make these devices ready with these kind of storage and ability to export power to the grid. Further, what we see is further important is that in these devices, we would require to upgrade the software, the firmware as the time goes by. Because when, say, the grid reaches to these devices, it may require some change in protocols. And if these devices are spread across on each farm, it would be very challenging to kind of go ahead and upgrade all these devices with the new firmware or the new algorithms that are required to ensure the optimal operation. So integrating IoT and better connectivity solutions is also critical. What we are seeing right now is that by 2030, at least 50 million such devices amounting to almost 50 gigawatts would be deployed in rural India. And these will be the future powerhouses for agriculture. So from that perspective, building a two-way connectivity system to get the data, to monitor, ensure their proper operation, and to also upgrade them when needed is also critical. So this is the kind of systems I think which are going to be important, wherein you're able to estimate the water level, you're able to look at the predictive diagnostics for the system, you're able to do the power management very effectively, basis the power cut scenario, basis the weather scenario, basis the water in the bore scenario. So AI is also going to play a critical role. So these kind of devices would be required to integrate the smart grid into the off-grid systems. Similarly, in case of cooling systems, we have again integrated the IoT and ensured that these kind of analytics and configurations can be done. We are able to program the systems remotely from here as well. So yeah, I think this is broadly what my 2 cents are, that the off-grid devices need to be also ready today when we are deploying them to be able to connect to smart grid, both in terms of the IoT and in terms of grid power export ability and the energy storage. If you don't do that today, as we have been, like if you look at the current Kusum Yojana, which is ongoing, there is no impetus on ensuring that these 3 lakh systems that are being deployed this year are going to be smart grid ready. So yeah, I think that is one area which is going to be quite expensive in the future. Thank you.
Okay, thank you, Mr. Devendra Gupta. You have mostly spoken about off-grid system and very innovative energy storage system also. You are working on that. It is a good, and I think innovative storage has a very big market, in future India. And storage is very important for any renewable energy sources because of intermittent nature of renewable energy. So thank you very much for excellent presentation. May I now go to the next speaker, Abhishek Manglik. He is the CEO, EcoSense Sustainable Solution Private Limited. Abhishek, you are there? Abhishek? Can you hear me? Can you hear me all?
Yes, sir, we can hear you.
You can hear me. Okay, then it's all right. Now we can go to the next speaker, Mr. Devendra Gupta. Thank you, Mr. Devendra Gupta. We can go to the next speaker now, Abhishek Manglik. You are there, Abhishek? Okay. Mr. Abhishek, he is the CEO, EcoSense Sustainable Solution Private Limited. May I now request you to make your presentation? Very short, very brief presentation within 10 minutes time.
Sure, sir. May I start, sir? Hello? Can you hear me?
Yeah, we all can hear you.
We
Okay,
can
sir.
hear you. You can start.
Yeah. So my topic is today's presentation is what role energy storage will play in integration with electrical grid. So the first thing is, why do we need energy storage? The whole idea of bringing energy storage is because we are getting used to putting so much of renewable energy into the grid. We are putting our reliability for behind renewable energy, and since renewable energy is intermittent source of power, when renewable energy was 5% generation capacity, 10% generation capacity, it was all right. But since renewable energy will going to be 40%, 50% generation capacity, maybe 25% of the power demand will be met through renewable energy, and being its intermittent nature, and we want to make our grid reliable, so energy storage will be deployed at different points in the grid to make the grid reliable and also operational friendly. So this is the whole reason why renewable energy storage is required. What are different kinds of storage devices that are being deployed different places? There are two types of storage devices. One is electrochemical storage. The other is physical storage. In electrochemical storage, we use batteries, lead acid battery, lithium ion battery, redox flow battery, supercapacitors. And in physical storage, we use something like pump hydro storage, compressed air storage, flywheel. But the most popular and the most widely used storage devices in the world is lithium ion batteries. Though there have been experiments being done using pump hydro storage also, compressed air storage also, flywheel also, at the lab level also, and at the large scale level also. But the most reliable and the most widely used storage devices in the world right now is lithium ion batteries. At what, where are we deploying these energy storage devices? So it starts from right at the generation level. So right now, there are many projects which are coming up where the developer has to supply electricity in the night time also. So at the, so it is we are deploying storage devices at the generation level and also at the transmission level to make at a transmission level for providing some of the devices like flywheels, and also at the distribution level where the distributor, who is a local distributor in Delhi like BSES we have, so to make its grid reliable and also for the peak power demand management, they are deploying the energy storage at the distribution level. So energy storage devices are being deployed at 3 different levels, from generation to transmission to distribution. In Delhi itself, Tata Power has deployed a 10 megawatt hour storage devices, storage unit right near the distribution center to take care of the peak loading. What services can energy storage provide? So energy storage can be very useful in the arbitrage. What I do mean by arbitrage is when we have power supply according to the time of the day supply, or when it is cheap, you can store energy in electrical storage and use it when the power demand is high for high power. Suppose during the day, when around in the morning when the power demand is low, you can store the electricity in the battery, and during the evening time around 6 a.m., 6 p.m., 7 p.m., 8 p.m., when the power demand is high, and also the time of the day pricing will come into the grid, you can supply power to the grid. Time of the day pricing has not yet come in, but it will definitely come in soon. Then it can take care of the peak power. So energy storage, one of the main reason of using energy storage, can take care of the peak power. And also something like black start. in a thermal power stations or gas power stations, when you are restarting the station because of any shutdown, you need a diesel generator to restart the generator. The same thing can be used with energy storage. Without using diesel generator, we can use energy storage to start to the black start, and some of the ancillary services can also be used using different kind of energy storage when it is in the grid side. These are some of the large scale grid projects which are currently being done. This is 10 megawatt hour project, one of the 10 megawatt hour project in Delhi, which has been deployed. Then Solar SECI has done a lot of the SECI has come out with tenders which are for 1 gigawatt hour grid scale battery storage devices. So these are the multiple projects which are at different level of deployment. So this is a brief presentation on where are we in terms of energy storage deployment at the grid side in India. Any questions, we'll be happy to answer.
Thank you, Mr. Abhishek. You have nicely explained the energy storage of different type. You have explained, which is very important, as I have already mentioned, that India is going in a big way. Solar energy and wind energy program, which are intermittent in nature. So storage is very important to stabilize the grid, and we must concentrate on storage. A lot of experiments are going on. Thank you once again, Mr. Abhishek, for making an excellent presentation on energy storage system and what is going on in India. And we are coming to almost the end of our session. Our last speaker is very eminent speaker, Professor Chandan Chakraborty. He is from Electrical Engineering Department, and he is also Associate Dean, SRIC, IIT Kharagpur, India. He is doing a lot of work in energy integration and renewable energy integration. I know him personally. So may I now request Professor Chandan Chakraborty to make his presentation, or he can also deliver a lecture.
Yeah, thank you, sir. It's a pleasure to be always with you. You are one of the pioneers, who started this renewable energy revolution in India. I also thank Professor Pablo Bajpai. Sir, you have referred him Professor Pradhan. He is not Professor Pradhan. He is Professor Bajpai, who introduced us all. Yeah. So I also thank him for introducing us all. Yeah. Now, well, I didn't make any presentation as such. I think the few things we can just discuss, I thought, because of the lack of time, because we are too many speakers and too less time. Well, you have given a topic, this 500 gigawatt challenge by 2030. That's really a big challenge. And then to that end, this quite, correctly connect also to our original topic of this, this panel discussion, which is entrepreneurship for microgrid or for smart grid. So what I feel is that, if we, today almost we are in 2022, and then we have only 8 years to reach to 2030, and then 500 gigawatt challenge is there. By 2030, we will see probably a far mega change. We are already exponential, and then we can clearly see to the extent we have renewable capacity integrated and in the way things are coming up. So it will have, very steep rise over there. And then I was also hearing the other experts who are presenting, and then particularly presentations by other, particularly up to this morning, I was listening to Dr. Suvir Sen, Power Grid, and then they are also preparing to take care of all these challenges. So that is one side, but if we really would like to go there, and then if we believe that everything will be done by government, it's not true. So the entrepreneurship should be encouraged, and entrepreneurship is already there. So let us see that how this entrepreneurship can be further encouraged. So we are in IIT Kharagpur. We have a school for engineering entrepreneurship, as you all know. where we encourage incubation for the startups, and there are very success stories. And in Shree Sponsor Research and Industrial Consultancy, there, of course, we support all sponsor research, industrial consultancy, and we also started a lab to market cell. So many of us, our academic members, faculty members, they are inventing many things, but that is not going to the market. So in Shree, this cell is actually helping. So there they need support in commercializing. They need support in legal issues and all. So those things will be helping. So this is just a kind information that we are actually working in that. And if we target, if we think of encouraging entrepreneurship, because if we try to reach 500 gigawatt, and that of course we would like to reach through Atmanirbhar Bharat or Shanirbar Bharat. So if we get all our products from outside and then connect it, and that way we reach 500 gigawatt, that's probably not desired. So that is all our plan. So in our institute also, our honorable director, he is encouraging us, every faculty member to come up also with product concept, because that's very, very important. That's a new trust that we all got nowadays, that not only just theoretical research, but we have to come up with product and encourage incubation, encourage entrepreneurship. And what I saw, what we all know, that in this area, entrepreneurship is already there, because out of 390 gigawatt, as I heard today from Dr. Suresh lecture, more than 150 gigawatt is already from private sector. So in the generating sector, it is already there. And to some extent, it's also there in transmission and distribution, but they have their restrictions, so that will be there. But when we think of renewable energy integration, well, this will come up with a lot of challenges that we all know, and then we are, through these conferences only, we are discussing challenges after challenges. And we have seen that the target, the figure now is kind of 47 gigawatt in solar, 40 gigawatt in wind, and from there, if we would like to go to the challenge that is set, is really a very, very challenging journey. And then in that, what I would like to stress, in our academic institutes, we are in fact doing a lot of research work connecting to solar. In IIT Kharagpur, we have consortiums, UK India consortiums, that many of you are aware. In there, we are actually working in different IITs, different NITs together. We are a consortium, and we have other partners also. And there we are already doing some indigenous work, kind of. We are coming up with stability studies. One of the work package was stability studies, where recently we have found that not just grid following kind of converter, grid forming inverter is a more stable solution. So there's a kind of know-how already we're generating. All of you know that when this solar or wind that will come in a more capacity, when they will be integrated, forecasting is very, very important. So we are also working in the project on forecasting. The project is going to be finished by next year. So there are different forecasting tools that we have proposed, and I can see also here also in this conference, that's a very popular, and a lot of other people, they're also working on that. Protections going to be very, very different in our work packages. Also in the consortium, we are coming up with new protection schemes. So, and then there are other, we have, when you talk about a microgrid, you are communications, and then supervisory control, because you can actually control each individual inverter or converter systems, how they will work. All those things are possible. We talk about the inertia challenge. So inertia challenge is, of course, if you have more and more inverter in the grid, you will face inertia challenge. But I always say that, well, you have probably in some area there is some limitations. Why not you convert this limitation into a kind of advantage? And that's already we are doing. And in the solar sector, already we are thinking of non-NPP kind of operations. And if you do that, you have of course storage needs to come up. When the storage will be economically more and more feasible, you can lean towards storage. But for the timing, we can probably work on also on non-NPP kind of things, and you can probably that way to some extent support inertia. Inertia issues are very, very important nowadays, because the capacity is less. The generating sector, solar or wind, they are just connecting or feeding to the grid, and probably in future they have also come up with definite inertia support. Without that, probably they will not be allowed to connect to the grid. So all those things are very, very important aspects. And we are what I want to say, not only in our project, but in smaller projects all through our country, there are research that is already available. And then what we need to do is the integration kind of handshaking kind of things with the entrepreneur, with this, with Power Grid, to this. We have actually held industry conclave through our projects, and that we had excellent experience over there where we actually shared our know-how, and then we visited the different industry and have seen that in some areas industry is they are doing things in a different way. In some areas we found that we are far ahead of industry, but the technology is not being used by the industry for definite reasons. So the gap is there. That was one I should stress. There was one more thing because we got a recent project, and that was and Dr. Gaun Chaudhary is also advisor in that project. I just did take a few minutes time to highlight that, which is actually forming a kind of independent grid, standalone grid in one of the islands in Sundarban area, which is Ghodamara Island. And there we are going to have, because there's no power, the grid has not reached over there, and then where we are going to make a grid, feeding power to those islanders, and there we will be actually doing a lot of experiments, particularly on smart metering and other issues. So that is also running up. So, and then that will be also a model. We'll create a model, sustainable model for business, promoting business. So we'll teach people, train people, and then that way we'll promote business about there. So that also going hand in hand. So this is from energy sector that we are doing, and many of us are doing. But I stress here that we need to have more and more hands shaking. And then when we think of entrepreneurship, I'll give you one example, because very recently I was chairing a session where in Ministry of Agriculture and Farmers Welfare, they have a program which is Rashtriya Kishan Vikas Yojana, RKVY, and under that they have created different nodes kind of thing, incubation center kind of things, in all through India, and IIT Kharagpur is one of them, and we have named our center like Agri Food Business Incubation Center, AFBIC. And then what we are doing over there, supported by the ministry, we created, they have created, I should say, like we have rather, two different programs. One is Agri Orientation Program, and another one is Agri Startup Incubation Program. Why I give you this example, because this probably can help. In Agri Orientation Program, we train people so that, and then we support people with a less amount of budget. And Agri Startup Program, we actually support people with slightly higher amount of budget. So that was there. So probably if we try to nurture more this entrepreneurship, promote more this entrepreneurship, we can also come up this kind of entrepreneurship program, rather proactive way, and then we can go ahead. So to summarize, because I don't have time, what I would like to say is that 500 gigawatt challenge is really very big, but this is of course not impossible. We have done many things in the past, and this is definitely doable. The Power Grid has already shown that they are ready. And the research part, what we should say that yes, the research are happening in IITs, in different NITs, and in corners of our country, but they are slightly in some cases, islanded kind of things. So they have to be connected, and then more and more industry conclaves need to be done. And once this handshaking is possible, I'm sure with proper training, proper informing the entrepreneurs about the regulatory framework and all, awareness program, and then if we can promote this entrepreneurship program, and then definitely, at least to some extent, we can probably reach that 500 gigawatt goal. Thank you.
So thank you very much, Professor Chandan Chakraborty. I'm sorry, it was Professor Bajpayee who introduced everyone. So I think our session is over already. It is 3. We are supposed to conclude at already 3:10. We are supposed to conclude at 3. It was a wonderful session. All the speakers, I thank all the speakers, starting from integration of what is a smart grid. We have started an integration of different energy sources into the smart grid, then EV charging infrastructure integration, distributed energy system. We have discussed energy balance, energy storage, last Professor Chandan Chakraborty has also discussed at length on entrepreneurship development. So it was a total program and it was quite interesting. I'm sure the audience has a lot of questions, but they can send the questions to the, in writing to the organizer so that they can send the question to the speakers because there is no time. Once again, I thank everyone, all the speakers. Really, they have made a nice presentation. Thank you very much. And thank you, Professor Bajpayee, for giving me opportunity to moderate the session. Thank you, IIT Kharagpur, for organizing such a big event despite of the COVID situation and other thing. So once again, I thank everyone. Thank you very much.
Thank you, sir.
Thank you. Thank you. Yeah.
So, Professor Bajpayee, you are there?
Bajpayee, you are muted.
Acha, he's muted. Huh?
Hello, can you hear me, sir?
Yes.
Okay, Professor Bajpayee, if you want to say something.
Sir, 1 minute. Sir, 1 minute. Hello, can you hear me?
Yeah, we can hear you.
Okay, sir. Thank you. So, sir, first of all, we have extended the next session by 15 minutes. So, please stay for 5 more minutes with us, because it's always a great pleasure for everyone to have such stars together at one platform and listening them together on at same agenda. So, let me take quickly 2 questions only, which we have received. Then I will take few minutes to conclude my part. So one question which has been came and already answered by Vishal. Can you go back to the answered part? So I will just read the question and answer also. The question was, can energy storage participate in power market in Indian scenario? So answer by Vishal was yes. A first BESS plus solar power project has been recently commissioned and started dispatching power to the Gujarat grid. This can also participate in open market subject to their contractual obligations. So I think Anushree, who has asked this question, must have got her answer. Can you go to the open? Yeah. So there is one more question, and from the panelists, whoever willing to take this, please answer it. Question is, can you please elaborate how the inertia problem can be used as advantage? So may I request Professor Chandan or Professor Ganchaudhary to kindly pass on the question or answer the question?
Okay, may I say something?
Please.
Okay, fine. It's a good question actually, because we always say that inertia is a big issue for solar power, right? Yeah. So yes, because of the frequency and inertia, they're related. So and when the solar power coming in, and then we always say that solar power connecting to the grid, there are a lot of issues. One straightforward kind of approach is you can go to a DC kind of grid, right? And because solar power is DC, and then you can go from DC to DC kind of thing, and then the frequency part can be taken up in a different way. The other part I already told, because you can still work in non-MPP kind of mode because you already have the reserve over there. And when you think of inertia from normal kind of machines, so they still take time. But when you have reserves, see if you are working on non-MPP kind of thing, and then this reserve is almost instantaneous, that is only restricted by the inverter capacity. So you can clearly see that you can even excel over synchronous machines at some time if your inverter allows that.
Yeah. So please, anyone want to add on anything or on this question? Or
I want, from the practical point of view, this inertia is very much required for the operation because it arrests the steep declining of frequency. But anyhow, this the question is that can we use the less inertia as an advantage of grid? No.
Yeah.
I think no, because we need inertia, but anyhow the resources which is causing the inertia declining can be used as a providing of synthetic inertia. Like
Yes.
because all the clean energy resources, RE and solar, they are connected through converters, inverters, power electronics. So that power electrons can be used providing a synthetic inertia.
Thank you very much, sir. I hope the person who has asked the question have got her answer. Now, I think we have no more time, and the other questions are not exactly the question. They have come as the suggestions. So let me close the question answer part here. Now I come back to the panelists again, and let me give a big round of applause first to all the panelists here. And I can say that I have the personal opportunity to work with Professor S.P. Chaudhary, and we are having a currently running DST sponsored project with micro solar dome, which he has invented. And we have got the opportunity to work with him all over the India, various part of India. And I have also got a chance to work with Mr. Sakat Raj Chaudhary. He has been involved with us in many projects in campus since my joining here. Devendra is my favorite student, and I remember the first energy audit project he has taken, where one of the mentor, I was there with Professor Kishore, and at that time, Director Professor Damodar Acharya appreciated it a lot, and we did a lot of work. And now I can say, Devendra, only that your recommendations are mostly fulfilled in campus, and we have adopted most of the recommendations made at almost more than 10 years back. So, and I invited him also because currently the director is from Department of Agriculture Engineering, and he is working in that area, which is really directly applicable to that domain. So I have personally requested him to come and visit and discuss his inventions with him so that we can work together furthermore. Abhishek Manglik also have a close relationship with me, and many of the projects, especially the new innovative projects we have done at IIT Kharagpur with the sun tracking system, single access, double access. He has helped a lot to arrange those setups at this place. And Professor Chandan Chakravarti is always a leader and inspiration for whole department and for me also. And I have got the opportunity to work with him. Two different projects, both Indo-UK joint projects. So I have benefited a lot with working with him. And I'm thankful to all the members, Shree Piky Agarwal ji, for your time and support and joining this session, and benefited to all of us once again. And thank you, sir. Thank you very much. We can close the session now. So let me announce the closing of this session. This is the panel session 2. We are closing now, and the next session will start at 3:30, which is a contributory paper session 5, which will be running in 5 parallel halls together on different tracks. So all the speakers of the papers and the session chairs are requested to kindly join the sessions. Thank you very much.
Yes, yes. So where is it? It has not come. No problem. What time is it?